You know who loves parabolas? Paul George. He loves parabolas. So much so that when he was hurt, he asked me to come to the hospital and teach him about parabolas. He said, algebra is number one. So we've looked at some different ways to get equations for parabolas, quadratic functions. If we have any point in the vertex, we use vertex form. If we have a point and the x-intercepts, we use intercept form. But if we just have any old 3 points that are on a parabola, we can write and solve a system of equations to find the quadratic equation for that parabola. Sounds like fun, huh? So in order to make sure that the 3 points we have are actually going to be on a parabola, there's a cool trick we can do. We look at the inputs of a function and then see how the outputs kind of behave. So if we're looking at a linear function, let's look at the inputs here, the x values. We got -3, -2, -1, 0, 1, 2, and 3. Those are our x values. And then our y values are, see, at -3, it's -1.5. At -2, we are at -1. At -1, we're at -0.5. At 0, we're at 0. At 1, we are at 0.5. At 2, we're at 1. And at 3, we are at 1.5. So these are our y values. What we do is we find the difference, or how far apart the y values are. And you find that with subtraction. So -1.5 minus -1 is +1. And we get -0.5 when we subtract these two. When we do -1 minus -0.5, that's plus 0.5, and that gives us -0.5. -0.5 minus 0 is -0.5. 0 minus 0.5 is -0.5. 0.5 minus 1 is -0.5. And 1 minus 1.5 is -0.5. So a linear function will have all the same, or we call them constant, first differences. So those are the first differences, the first time we subtracted the outputs at evenly spaced intervals, and they're all the same number. If we look at a parabola, or quadratic function, we can look at the same inputs here. Now we'll look at our outputs. At -3, we're at 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, and 3, 5. And now let's check the first differences. 5 minus 0 is 5. 0 minus -3 turns into +3, so that's 0 plus 3 is 3. -3 minus -4, that's +4, so that's -3 plus 4 is 1. -4 minus -3, so -4 plus 3 is -1. -3 minus 0 is -3. And 0 minus 5 is -5. So these are our first differences. And now let's check our second differences. We'll do 5 minus 3. 5 minus 3 is 2. 3 minus 1 is 2. 1 minus -1 is 1 plus 1, which is 2. -1 plus 3 is 2. -3 plus 5 is 2. So a quadratic function has constant second differences. So linear data have constant first differences, quadratic data have constant second differences. So if we are just given data and we don't know if it's quadratic or linear, we can check the differences to see if a quadratic equation will be good for modeling that data. So here's some data. Can these data be modeled with a quadratic function? Let's find out. We've got our inputs evenly spaced, and let's find the differences of our outputs. 9 minus 4 is 5. 4 minus 1 is 3. 1 minus 0 is 1. 0 minus 1 is negative 1. 1 minus 4 is negative 3. And 4 minus 9 is negative 5. Second differences. 5 minus 3 is 2. 3 minus 1 is 2. 1 minus negative 1 is 1 plus 1, 2. Negative 1 plus 3, 2. Negative 3 plus 5, 2. So we've got constant second differences. So that indicates that this data can be modeled with a quadratic function. So now let's actually do one. We got some data here about NASA flying a plane in a parabolic path. They kind of like fly up and then back down. And then right around here, everybody gets to feel weightless, and it's super fun. At least it seems like it would be. So first, let's make sure these data can be modeled with a quadratic function. So let's check our, see these are evenly spaced inputs, 5 units apart. And then let's check our differences. Subtract there, you get negative 2125. Checking all these differences. I'm assuming you can do that with a calculator. And we do this with a calculator. Look what happens. Magic. Constant second differences. So we can use a quadratic function to model this data. So if this data can be modeled with a quadratic function, height will be a function of time. So h of t. And then we need to find out what a, b, and c are going to be. But it'll be a times t squared plus b times t plus c. So what we need to do is pick 3 points from over here. I'm going to pick the ones that look easier, like 10, 20, and 30, and the corresponding height values that go with those 3. And we're going to plug those in for t and h, right? All right, so let's take a look at this point, 10, 26,900. So our height is 26,900. T is 10, so 10 squared plus b times 10 plus c. So we are looking at 26,900 equals 10 squared is 100, so 100a plus 10b plus c. So I will write that in purple with a more neat pen. And then we'll take a look at our next point. So h is 30,600. T is 20. So that gives us 30,600. 20 times 20 is 400. So 400a plus 20b plus c. There's our second equation. And then we can grab our third point to make our third equation. Our height is 32,100. T is 30. So 30 squared is 900. 30 times b plus c, and there's our third equation. All right, so now let's solve this system. All right, so we've got 3 equations. Just for convenience, I'll call them equation x, y, and z. And in order to solve, I need to start off by canceling out one of the variables. And it looks like c is probably the easiest one to cancel out. And since equation z has larger numbers for coefficients on a and b, I'm going to pair z up and I'm going to subtract off x to get a new equation without c in it, and then I'll subtract off y to get a new equation without c. So let's start off doing z minus y. So here's z, and then minus y, I'm going to multiply everything across here by -1. So it's going to be negative 30,600 minus 400a minus 20b minus c. And you can see that the c's are going to cancel out because c minus c is 0. So my new equation that I'm going to get will just have a and b, and I get 1500 equals 500a plus 10b, and I'll call this new equation w. And I only do that to help myself keep track of what I'm doing. Colors help too. So now we've got one equation that only has a and b. Let's pair z up with x now. We'll do z minus x to get an equation that's different from this one that still only has a and b. So here's z again. Minus x means I'm going to subtract each one of these parts. And my new equation that I get is 5200 equals 800a plus 20b. And I'll just call this equation v. Now, I'm going to take the two equations that I got that have just a and b in them and solve that system of equations. You can tell I got 10b here and I got 20b here. So if I multiply w by -2, then my b's will cancel out, right? 10b times -2 is -20b, and that'll make my b's cancel out. So I multiply everything in equation w by -2. So I get -3000 equals -1000a minus 20b. And then, so my b's are going to cancel out, and I'll get -200a and 2200. So now I'll just divide both sides by -200, and I will get a equals -11. So that's part of my answer. I know what a is now. Remember, I got to get a t squared plus b t plus c. So I still need to get b and c. Now that I have a, though, I can plug -11 into either w or v to be able to solve for b. I feel like I'm saying a lot of letters. Sorry about that. Let's take this equation and we'll plug the -11 in for a and solve for b. 500 times -11 is -5500. We're going to add 5500 to both sides. We get 7000 equals 10b. Divide both sides by 10. And we get b equals 700. Now that we have a and b, we can plug back to any one of these three original equations to get c. So I picked equation x because it has the smallest numbers. So I'm going to plug a -11 in for a, plug 700 in for b, and then we'll figure out what c is. So we're going to multiply here, combine like terms here, subtract 5900 from both sides. 21,000 equals c. So the equation that models the flight of that plane is h of t is -11t squared plus 700t plus 2100. Bless you. Bless your dear little heart. You're a wonderful person.